Okay, so this is for Math 170. It's the mortgage question. I wanted to show you what it looks like in Octave first. Octave is free, by the way. I don't know how to get it to work under Windows or Macs, but it's really easy to get it to work if you have Linux, and you can always get a Linux virtual machine if you like. But this is what the commands would look like in Octave. Open? Okay. Alright, so anyway, this is what the plot of U looks like. And as you can see in a normal type of environment that is not Wolfram Alpha, you could just plot two plots one on top of the other, and then when you mouse over, see it down in the corner, it tells you where your mouse is. So if I say, oh, here's where it's crossing, the hairs are crossing right about there, then we're talking about maybe year 25 or 26 as when you're halfway paid off, because this top curve was U, and that's, what does it say U is? The amount that is paid towards the interest is U, and then V is the amount that's being paid towards the principal, and you see they have to add up to the same value, whatever that value is that's close to 800. What was it? 809 was your monthly payments. So your monthly payment, when it gets down to zero, you've paid off your house, and 100% of it is going towards the principal, okay? But you have to wait until the last 10 years of your loan to be making some headway. And so the takeaway I wanted you to see from this is, if you can accelerate yourself on this curve at all, that's wonderful. Like if you can just early in your mortgage or school loan or anything like that, if you can say, all right, I'm going to check up, put an extra $100 every couple months just towards the mortgage or towards your school loan, what it's going to do is it's going to inch you along this curve much faster, because you see, when you're between, let's say, years 5 and 10 or 0 and 10, see how hard it is to increase the amount of your payment that's going towards principal, right? So if you can hop yourself over a little bit, it just inches you all that faster along that edge of the curve and helps you pay off the loan much faster. Okay, so I want to show you now how to do this using Wolfram, because that's what's free and available online without having to install anything. And so what you want to do is first open up this email. If you type Wolfram Alpha, that's not a bad search term. I don't suspect most of you are talking about Wolfram Alpha with your friends all the time, so hopefully that'll help you find the email. And then I'm going to open up Wolfram Alpha over here. Okay, now I should be able to take this. This is all of U. This is not U and V. This is just one of them, because for whatever reason Wolfram is being difficult with me and not letting me plot two things at once. Okay, so I'm only going to plot one of them, but if you remember, let me go back to my other plot. Remember how there's this symmetry? Everything adds up to 809 or whatever it is. So in order to find out where these two curves will cross, you want to know roughly when you're at about the 400 level. Okay, so you can eyeball when that's going to happen without plotting both of them. Alright, so this is kind of a small picture, but at least see it has this little cross here. So you see where we're at about 400. You come over to here, and that's about what you're looking for. You're looking for about maybe, wait a minute, is that the same thing that I had over here? So over here, it said that I was crossing, and I got like 25 and a half. And let's see, over here, at about 25 and a half, that's nowhere near the same. So I'm going to pause this and see if I can figure out what's going on. Okay, I figured it out. So what happened is, in the email I sent you is for your version of the textbook, but the version of the textbook I have in my house is an old version, so the monthly payments were different. So this is kind of cool, because in your version of the textbook they just bumped up the monthly payment by, let me see how much. So it was, for me it was $809.39, and then bumped it up to $839.06. So they bumped the mortgage up by $30 a month, and it actually helped tremendously because in this example over here, you didn't start really making some headway on that loan until 25 years. But over here, you ended up making headway a lot sooner, and those curves will cross earlier. See, isn't that cool? Oh, that's awesome. I didn't even realize I had two different versions of the same problem. Whereas if you just drop your payment by $30 a month, look how much longer it takes you to get, you'd be over here roughly before you start making headway on that loan. This is really cool. Okay, hopefully that's helpful to somebody. I think I'm going to pause and then I will talk about the other question. Okay, going on to the next home mortgage question. So I gave up trying to do it in Octave, and I'm suspicious that there may be a problem with the formula. I have to investigate that more closely. But I'm going to just show you, assuming that the formula is actually correct, which it might be, I'm going to show you how to just do the exercise as given in the book. Okay, so you look at my email and you just copy this line here. Alright, copy, go to Wolfram, dump it in, okay, and then you wait for it. Alright, then you come down here, wait for it, okay, where it says result. Click on the result, and the magic that happens is you sit there and wait longer. It dumps the result back into the window. I don't know why this helps. It shouldn't help, but it seems to help. Now we write plot or graph, same thing. Open parentheses, 1, 2, 0, 0, 0, 0, times, open parentheses again. We've now opened two sets of parentheses, so we close two sets of parentheses. T equals 1 to 30, something like that. Okay, or I think I said T equals 0 to 30. 0 is a bad thing to put in here. I should put 1 to 30. Let's see. Well, it plotted it from 0 to 30 anyway. I don't like that. Here's why I don't like that. It's telling you that you're starting off the loan before you've even made a single payment. It's saying that you've paid like $25,000 in interest, which doesn't make any sense because you just started paying off the loan. So this is why I think there may be a problem with the formula. But this is really what this formula is. It's really plotting this formula, and this is the formula given in the book. So there's something I'm not getting, but here's your P from the book, and Wolfram Alpha puts the -1 up front instead of at the end of this fraction. There's your R times T, and here's in your formula 1 minus, and this came from 1 over 1 plus R over 12. Let me pause this again. Yeah, I'm still thinking this over, as you can see. But in the book, the denominator is RT in the numerator, that's fine, divided by, and then in the denominator we have 1 minus, and then a fraction to the power of 12t. But that fraction is the reciprocal of 1 plus R over 12. But 1 plus R over 12 should be just slightly higher than 1. So its reciprocal should be slightly lower than 1. And that's what we've got. So this looks like the formula in the book. I'm pretty sure I typed it incorrectly. I've checked it several times. You guys are free to check it again. But this looks right. And so it says the total interest paid on a home mortgage of P dollars, in this case we used 120,000, at an interest rate of R, the interest rate we took from the last problem, which is 0.075, and T years, so we're considering it up to 30 years. And so there you go. So I just wanted you to practice with Wolfram Alpha, typing in financial formulas, or at least cutting them and pasting them, and just looking at them. In this case, it's saying that after 30 years, you're going to have, I don't know, we'll see, we're all the way up here, 150, 160, 170, 180, looks like 180,000 is the total interest paid on that house. So you're paying more than the value of the house. You're paying for the house twice. Once for yourself to live in it, and once for the bank for the privilege of helping you buy the house. You buy a house for you and a house for the bank. So if you wonder why banks are rolling in the money every time they're trying to be quote unquote nice to you and say, oh, we'll give you a loan, we'll help you live your dreams, what they're doing is they're basically saying, buy us a house and then we'll let you have the second house. Yeah, so you're buying the house twice.